an equation like y equals f of x, it tells us what y should be for each value of x. In other words, it's telling us the relationship between the variable y and the variable x. So let's suppose, for example, we take the function f of x equals 2x plus 1. Then the relationship between y and x is explained by this line. So for each x, we get the corresponding y. So this equation describes this line. A single equation like this isn't going to tell us what x or y has to be. It just tells us the relationship between x and y. Suppose we plotted the graph of this function g as well. So we have another equation, y equals g of x, for some other function g, which is x plus 3 over 2. Then we get this other relationship between x and y. So when you have two equations, y equals g of x and y equals f of x, then you've got two different relationships between x and y. So now you can find out at what x and y do both of these equations hold true. Graphically, that's just the point where these two lines intersect. So in this example, when x equals a third, y equals 1 2/3, both of these relationships, y equals f of x and y equals g of x, hold true. And that's what we call the solution to this system of equations. We've got one equation, we've got two equations. So given two equations, we can figure out two unknowns, x and y. Typically, to be able to find any number n unknowns, you need n equations. So what I've shown you here is how we could solve the two equations, y equals 2x plus 1 and y equals x plus 3 over 2 for the two unknowns x and y. This is a graphical representation of that solution. So to summarize, we solved the two equations y equals 2x plus 1 and y equals x plus 3 over 2 graphically and found that both of these can only be true when x equals a third, which would mean that y is 1 2/3. Graphing the equations and measuring out the point where they intersect isn't always going to be the most efficient way to solve these problems. What we can do is that we can manipulate equations to find the solution. So what we want to find is the x where both of these things are true. So y equals 2x plus 1 is true, and y equals x plus 3 over 2 is true. So if we have an x and a y, so that y is 2x plus 1, and it's also x plus 3 over 2, then 2x plus 1 has to equal x plus 3 over 2. So we've got now an equation with one unknown, and we can solve that for x, using what we learned about manipulating equations. So let's start with this equation. And the first thing we'll do is multiply both sides by 2. So we've got 2 times 2x plus 1, which is what we had on the left side, and 2 times x plus 3 over 2. We notice that the 2 and the 2 are going to cancel. So we've got 2 in the numerator and 2 in the denominator. So the right side just becomes x plus 3, and the left side, we're going to distribute the 2 between the 2x and the 1. So we get 4x plus 2. So 4x plus 2 is equal to x plus 3. That's our new equation. And we're going to continue to manipulate this equation until we solve for x. So let's subtract x plus 2 from both sides. I'm doing two steps in one. I could have subtracted x and then subtracted 2, but we'll just do them both at the same time. So we'll subtract x plus 2 from both sides of this equation. So on the left side, we've got 4x plus 2 minus x plus 2. On the right side, we've got x plus 3 minus x plus 2. Some of these things are going to cancel out. We've got a plus 2 and a minus 2, so the 2's are going to cancel on the left side. On the right side, we've got an x and a minus x. The x's are going to cancel on this side. So now we're left with, on the left side, 4x minus x, that's 3x. And on the right side, we've got 3 minus 2, which is 1. So we get 3x equals 1. We're almost there in terms of solving for x. We're just going to divide both sides by 3. So we've got 3x on the left side, 1 on the right side. Divide both of them by 3. The 3 in the numerator and 3 in the denominator cancel. So we're left with just x. And the right side is just 1/3. That's the solution we found when we solved graphically. So now if we want to find y, we just use either of the original equations. Either we can use 2x plus 1. So y equals 2x plus 1. So x we know is a third. So it's 2 times 1/3 plus 1. So it's 1 2/3. Or we could have used y equals x plus 3 over 2. Since x is a third, so it would be 10 divided by 6, which is 5 over 3, which is 1 2/3. So that's how you solve two equations. In this example, y equals 2x plus 1 and y equals x plus 3 over 2 for two unknowns, which are x and y. Solving two equations and two unknowns is going to be useful when it comes to solving the equilibrium of a market, for instance, One equation is going to give you supply, the other equation is going to give you demand. So x and y are going to be the price and the quantity, respectively. Given two equations, one that comes from supply and the other that comes from demand, we can solve for the two unknowns, which are price and quantity.